actually make sure of that. Okay, I don't want everybody to see my butt. You know, when you're studying economics, that's weird. Okay, should we start? Okay, so please. So the next 15-20 minutes is basically it's gonna give me a heart attack. I'm gonna talk very, very fast because I'm gonna summarize the whole course in 20 minutes. So it's gonna give me and you a heart attack probably following me. The idea of this whole thing is that right now it makes sense what I'm saying, and you build up, okay, oh, this is related to this, like this, like this, like this, and everything makes sense. Of course, I have studied this topic, hopefully, right? And I know it by heart. You need to study, right? So I'm not assuming everybody will understand absolutely everything I say. You still need to study. But at least, you know, things, when I'm talking right now, things should fall in place, and things should start to make sense, right? Okay, so stop the video and start. Okay, no, sorry. Okay, and then the nice thing about the video is you can stop it, you can pause it, so it will help you. Okay, but if when I'm talking in the next 20 minutes there's something that doesn't make sense, probably it will not make sense for you and for many others. So please stop me and ask me. And it's nice that the question is also recorded on the video, etc. So if I say something that doesn't make sense, let me know. Okay, should we start? Okay, so what is this course about? So the course is about how competition drives the results of a market, right? What do we mean with the results of the market? We mean the prices at which products are sold and how much quantity is sold in this market, right? With competition, what we mean is whether there are many competitors or few competitors, right? In order to talk about what prices are going to be in a market and how much quantity is going to be sold in a market, we are looking at firms. We are looking at firms who are making good decisions. We are teaching you how to make good business decisions, not bad decisions. So assuming everybody is making the best decision, and in particular following the objective of maximizing profits, right? So firms in our market are going to try to maximize profits, right? In order to maximize profits, you need to actually maximize what profits is, which is revenue minus cost. Revenue is price times quantity, right? And the cost comes from your cost function. So you need to know what are your costs of producing something, and you need your cost, and you need to know, you know, what is the relationship, the inverse relationship there is between the price that you're charging for the product and the quantity that you can sell for your product. Why? Because most goods that you will be selling in a market are not given goods, right? Meaning, if the price is higher, you will sell less units. If the price is lower, you will sell more units. So there is a trade-off between price and quantity. And that's why you have to play around with this idea. If goods were given, the world will be wonderful because you would charge higher prices and you would sell more. But most goods are not given, right? So, what I mean is that in order to play around with this trade-off between price and quantity, right, what you need to know is, okay, how the two are interrelated, and in particular, if you lower your price, how many more units are you going to sell? Meaning, you need to know the demand for your product. The demand for your product is at each price, right? How many units of my products I will be selling. In order to know that, something that is very useful is to try to get data on what is the maximum willingness to pay people have for your product, which of course consumers will try not to reveal. In our exercises, we will be giving the demand and it's easy, but normally you don't know it, so you try to come up with strategies to know what is the maximum willingness to pay there is for your product. Of course, the demand will be downward sloping, so there will be some people who are willing to pay really, really a lot for it, but some people who are not willing to pay so much. So the lower the price, the more units you will sell, right? And that's the demand function. It's an inverse relationship between price and quantity, right? Fine. So you will try to decide a point in that demand function. I'm selling this number of units at this price. However, whether you can choose that point or not will depend on two things. One is whether you have competition or not. If you have a lot of competition, actually you cannot decide a point. You are just one of many in the market. You are given a price and then you decide whether you want to sell or not at that price, but the price is given. And also, what are your costs, right? We saw the same way that we see that the demand function is willingness to pay, we see that the supply function comes from the marginal cost. Why? The supply function is the minimum price they would have to pay you in order for you to supply those units. Well, in order to supply units, at least the price has to cover your marginal cost. And in particular, we had a discussion that says it actually has to cover the marginal cost whenever the marginal cost is above the minimum of the average cost, right? So the supply function is the part of the marginal cost function that is above the minimum of the average cost, right? Once we have demand and supply, we will calculate what happens in the market depending on whether we are in a perfect competitive market, a monopoly, or an oligopoly. But before we do that, we play around a little bit with the demand function in order to understand how the demand function depends. Actually, our simple graph of the demand function just depends on prices and quantity. But actually, the demand function could move around depending on other things that we are not putting in our graph. In particular, income and the prices of our competitors, right? So if this is my demand function and my good is normal, when income increases, the demand function will shift upwards, right? Because people who have more money and who like your product means that when really like your product, when they have more money, they will be willing to pay more for it. So the demand function shifts upwards. It could also shift inwards. So if the good is inferior, more income means lower demand, right? So we classify goods as normal or inferior depending, of what happens to the demand, right, when the income changes. Another crucial thing is what we call the cross price substitution, right? So we care about what happens when the product of my the price of the product of my competitor goes up and down, right? We define two goods as being substitutes as if the price of my competitor goes up, my demand goes up. Those are substitutes. The price of my competitor goes down, the demand goes down, then they are complements, right? And most importantly, what we look at in the demand, given that it's a relationship between price and quantity, we look at how reactive the demand is to changes in prices. Ideally, we want the demand to be not reactive at all, right? We want that no matter how high the price is, the quantity sold is always the same. That's what we want, right? But most demands are elastic, or at least they are elastic at some points. So we define the elasticity as how much the quantity reacts to changes in prices. We don't do just the derivative, which is actually the derivative of the quantity with respect to price. We actually do what we call the elasticity, which is the derivative of the quantity with respect to price multiplied by price and divided by quantity. Why do we do that? Because in that formula, then the numerator is price times quantity and the denominator is also price times quantity. So this is a percentage. Basically, an elasticity is saying if you change the price in 1%, the quantity consumed changes in what? More than 1%, the same as 1%, or less than 1%, right? When that change is less than 1%, we say that we are at a point in which the demand is inelastic. When it's zero, it's completely inelastic, it doesn't react. When it's larger than 1%, then we are at a point where the demand is elastic, right? Now, depending on whether we are at a point where the demand is elastic or inelastic, we may want to change prices, we may want to raise or lower prices. If the demand is elastic, meaning the elasticity is bigger than 1, it means that if I raise my price in 1%, the quantity demanded is going to decrease in more than 1%. So bad idea, right? Because your revenue is going to go down, right? If you are in the inelastic part, it means you can keep raising prices because the more the price you charge, the more money you will get, but the quantity will not react a lot. So we saw that you actually maximize revenue at the point where the price elasticity equals 1. That's the maximum. That's where what you get in terms of price, you're raising the price in 1%, is exactly offset by what you lose, which is the quantity consumed is less than 1%. So it's the point, the maximum revenue, right? Now, we also saw that one problem is, of course, to maximize revenue, but the main problem we are focusing on in this course is maximizing profits, right? The problem of maximizing profits takes into account that we want to get a lot of revenue, but also has to take into account the cost, right? So perhaps you are in a very, you want to keep raising prices, or you want to keep producing more and more and more. But if producing those units costs you a lot, perhaps it's a reason not to produce that much. So, in order to maximize profits, you have to take into account the two effects. And we saw a relationship when we were solving the problem of maximizing profits with respect to quantity, take that derivative and equal to 0, we were solving that we would get an expression that is very close to the elasticity. Actually, at the end, we got an expression that tells us that the markup, meaning the difference between the price I can charge in a market and the marginal cost, P minus the marginal cost divided by P, but what the important thing is the numerator, price minus the marginal cost, is an inverse relationship of the elasticity, 1 divided by the elasticity. So if the elasticity of my product is higher, 1 divided by something big is going to be small, so the markup is going to be small. The larger the elasticity, the smaller the markup. Okay? Make sense? So those were properties of the demand that we look at different elasticities. Then we concentrated on competition. So we saw, okay, so which type of competition could I have? I could have 3 types of competition. Perfect competition, monopoly, and oligopoly. Perfect competition. Again, in all 3 cases, I'm solving exactly the same problem. I'm trying to maximize profits, and I always maximize profits where the derivative of profits with respect to whatever I'm deciding, in most cases it was quantity, equals 0. And the solution to that is the tattoo everybody should have, which is marginal revenue equals to marginal cost. Now, what are the difference between the problem of perfect competition, monopoly, and oligopoly? So the difference is that always revenue is always price times quantity, but in perfect competition, I'm a price taker, meaning with how much I produce, I don't change the price, right? I have to take the price, whatever price, where demand equals supply. I have to take that price. I cannot, if I produce a little bit more, a little bit less, I'm just such a tiny fraction in the market that I'm not going to affect anything, right? I'm not going to affect the price. So I'm a price taker, right? And because I'm a price taker, the price is going to be equal to marginal revenue, which is equal to the marginal cost. And this is how I would solve the problem. However, when I'm a monopolist or when I'm in an oligopoly, I'm no longer a price taker, meaning with how much I decide to produce, I'm going to be altering the price. And when I calculate the marginal revenue, it's no longer to be the price, which is a number multiplied by the quantity, so the derivative is the number. The marginal revenue is the price. No. Now, when I calculate the marginal revenue, the Q is here and here. So I will have to take the derivative with respect to the Q's. And the Q1, which is what I'm deciding, in oligopoly is here and here. So I have to take it into account. Before we move to monopoly and oligopoly, one thing we discussed when we were talking about perfect competitive markets was were 2 things. One was welfare, right? So we were saying that in a perfect competitive market, there's the maximum total welfare there can be. And we were saying it's efficient. Why? Because we are producing at a point where the value, what consumers are willing to pay for those units that are being sold, actually is larger than the value, what producers are the price at which producers are willing to sell this product, right? And we were saying that the consumer surplus is, if this is the price and this is the demand, is the upper triangle in this graph. If this is the price and this is the supply, the producer surplus is the lower triangle. So the sum of the 2 triangles is the maximum welfare we can get in a market, right? Why do we measure the welfare of consumers as consumer surplus? Why do we measure welfare as the difference between willingness to pay and the price you pay, right? And that's why we have this whole triangle. Because, well, given that we are measuring the surplus of producers as, the price they are getting minus the cost, so basically we are measuring the welfare of the producers in terms of money, right? We want to be able to compare, in order to do welfare comparisons, we want to be able to compare the welfare of producers with the welfare of consumers, right? So we want to measure the welfare of consumers in terms of money. What is a way to do it? Well, when you ask a consumer, what is the difference? How happy a consumer is the difference between how much he's willing to pay for something and how much he actually has to pay for it. So, if I'm willing to pay 30 euros for this sweater, but I only have to pay 10, I'm 20 units of happiness, which is weird, but it's the way we are measuring happiness, right? And now welfare will be the sum of how happy the consumer is and how happy the producer is. Now, if in a perfect competitive market, which has to satisfy many things, many producers, many consumers, perfect information about the prices, all transactions are being done, right? Those are the main 2 assumptions, right? But there are others. Everything that was going on in the experiment that we did in class, in that case, if we let a perfect competitive market be, the point that the market will reach, where demand equals supply, will give us the most efficient thing, the maximum welfare we can get. However, we saw that if a perfect competitive market, we alter the prices, we try to change the prices or change the quantity that it's consumed. For example, we don't want so many people to smoke, right? we want to reduce the quantity of tobacco that is sold, for example, or we want to get revenue from tobacco, we can change the equilibrium of the market. How we do it? Through taxes, through subsidies, through import taxes, through minimum wages, maximum prices, all these things, all those interventions that we were limiting quantity that can be sold. However, we see that we need to understand how all those exercises are done with taxes, subsidies, etc. But the important thing that we learn is, of course, with those things, the equilibrium and the price that are sold in the market are going to change. And of course, some people may be better off and some people may be worse off. In particular, with a subsidy, both producers and consumers of the products are better off. But the problem is that we are going to create an efficiency loss, meaning perhaps the welfare that we are creating is offset by the cost of the measure. Or in the case of a tax, right? The tax will increase the prices for consumers, so consumers will be worse off. Producers will reduce their quantity and probably the price they receive will also be lower, so they will also be worse off. And we say, okay, but still we get money, we get tax revenue. Well, and with that money we can do things that people like, yes. But the tax revenue that you're getting is smaller than the reduction in the loss, of the welfare of the consumers plus the loss of the welfare of producers. So there's that triangle of efficiency loss that you need to know how to calculate. So altering a perfect competitive market creates an efficiency loss. Okay, that's about perfect competition. Now, monopoly. The difference is, instead of many firms, there is just one firm who can actually now decide how much to produce in order to play this trade-off between price and quantity in a way that is the best for them, such as they maximize their profits. So they choose a point in the demand curve. How is this point calculated? Well, where marginal revenue equals marginal cost. But this is very important. Marginal revenue equals marginal cost gives me the monopoly quantity, but it doesn't give me the price. I have to take that quantity all the way to the demand function and I find the monopoly price. Again, because we are selling less units than under perfect competition at higher prices, right? We are creating an efficiency loss. It's true that the producer is better than under perfect competition, but the consumer is worse off. And some part of what the consumer is losing, the producer is recovering, but some part is lost. So there is an efficiency loss, right? One way to recover that efficiency loss is perhaps to make monopolies be public, right? A monopoly that is public may produce the perfect competitive equilibrium quantity, right, and may charge whatever price they do, and they can afford making losses. But again, subsidizing this monopoly is more expensive than the increasing welfare that you are creating. Okay? Now, of course, that's the monopoly when the monopoly is forced to sell all the units that they sell at the same price. But what if, given that they are the only ones selling this product, they may know a lot of information about the consumers. If they legally can do it, and they actually can keep consumers separated, such as they don't start trading and so you are no longer a monopolist because others are trading. If you can keep being a monopolist because the others don't tell each other at which prices they're selling, it's better, as a monopoly, it's better, instead of charging just one price discriminating. Price discriminating means selling different units at different prices. The best thing you can do is what is called perfect price discrimination. Each unit is sold at the maximum willingness to pay for it. And actually, from the point of view of welfare, it's also great, right? Because we are producing again at the point where demand equals supply. But in terms of welfare, all the surplus now is for the producers. The consumers have no producer surplus because the producer no consumer surplus because the producer is selling each unit at the maximum willingness to pay for it. Okay? So that's perfect price discrimination. For that, you need a lot of information. You need to know exactly how much each consumer is willing to pay for each single unit. In most cases, you don't know that, but perhaps you have information that people of different types, they have different demands. If you actually can identify who is who, and when they come to your store, you know who is this type and who is this type, and you can know who is who, what you can do is behave as a monopolist with the demand of this type of people, and behave as a monopolist with the demand of this type of people, meaning you solve the same problem, but with two different graphs, two different demands. One price for all the units sold to consumers of this price, of this type, one price for all the units sold to consumers of the other type. Keep the market separate. And there you recover part of the consumer surplus that you are losing with respect to perfect price discrimination. Most likely, in many cases, you don't know who is who. You know the types exist, but you don't know who is who. but perhaps with your pricing policy, how you charge things, perhaps you do bundling, perhaps you do three times two, perhaps you have two different types of your product, whatever. Those things are done not to benefit the consumer. Those things are done in order to capture more of the consumer surplus. You put two different tariffs for different types of consumption choices, and people self-select. Those who prefer one thing, they will buy one thing, the other, but you're capturing as much consumer surplus as you can. Okay? That's basically why do we talk about price discrimination only when we talk about oligopoly? Well, because if you have competition, of course you cannot charge two different prices, because if you have competition, somebody will charge a lower price than your higher price, right? So as long as you have competition, you cannot price discriminate. Now, let's talk really about the middle case, the interesting case, which is competition. What happens in oligopoly when you have a reduced number of firms? For simplicity, let's assume it's two, right? Where your the price at which this product is sold, it's affected by your decision of how much to produce, but also by the decision of the other, right? Again, the problem is exactly the same. Each firm is going to try to maximize their profit, so you have to set the profit maximization problem of each firm. This maximizes the profits, deciding what do they decide. So they take the derivative with respect to whatever they decide. These guys take the derivative with respect to whatever they decide. Again, this guy marginal revenue equals to their own marginal cost. They only care about the units they are selling and the cost of producing those units. They don't care about the cost of producing the other guy. Same here, and then you solve the system of equations with unknown, and you find what it's called an equilibrium. An equilibrium is a situation in which everybody's in their best response function, meaning they are doing the best thing they can given what they expect to, and the other will be doing. And a part of that, what they believe the others are doing is actually what they do. We discussed many models of competition, but basically the way to proceed is exactly the same. Write the profit maximization problems, take the derivative with respect to whatever they're deciding, equal to 0, and solve the system of equations with unknowns. What are the models we discussed? So we discussed first, Cournot competition, meaning meaning firms deciding simultaneously how much to produce, right? We solved that problem, and we have an example in the slides of how to solve that problem. And then we saw, but you know, the equilibrium, the Nash equilibrium of Cournot competition is actually a dilemma. It's like the prisoner's dilemma, because perhaps by competing too much, we are creating in total too much production, and therefore the prices are low. Perhaps would be best to collude and reduce production in order to keep prices high. But then we see that if you don't care much about the future profits, if you just care about one future, collusion cannot be sustained, right? We saw differences not only with respect to collusion or not. We saw, what if the two firms have different cost functions? Well, the two problems, you keep them separate, they have different cost functions. Whichever firm is more efficient, meaning whichever firm has lower cost, in equilibrium will produce a little bit more than the one that has higher cost, right? What would happen if the competition, instead of being simultaneous, is sequential? One decides first, the other decides second. Intuitively, we thought that being the second firm is always better, because you see what the other does and you take your best decision. However, that intuition is wrong. Why? Because the second firm, the one that comes second, can only adapt to whatever the first firm has done, right? So it's better to be the first one and force the second one to actually adapt to what you do. So there's what we call a first mover advantage, right? You firm one, decide how much to produce, taking into account how the other is going to react. So you incorporate their best response function into your function, right? And then you solve the problem for firm 1, and then you substitute it in the best response function of firm 2, you find how much firm 2 produces, and that gives a price, right? That is what we discussed about competition in quantities. Competition in prices, much easier, because you don't have to take derivatives. The best response, when we are competing with an homogeneous product, the best response is to whatever price my competitor is doing to undercut it. If we have the same marginal cost, the equilibrium is going to, and the product is exactly homogeneous, the equilibrium is going to be price equals marginal cost. So actually we're going to be back again in the situation of perfect competition, which is the same total quantity as in perfect competition, the price equals marginal cost, which is the price of perfect competition. However, if the two firms competing in prices, they have different marginal costs, they will undercut each other until the one that has lower cost charges a price just below the marginal cost of the other, and steals the whole market. This one cannot go lower because they will be making losses, and the one that has lower cost behaves as is a monopoly, it's the only one in the market, but not charging monopoly prices, but charging prices equal to the marginal cost of the other firm minus epsilon, right? Okay, now, if, we're almost there. Now, if the two products are differentiated, the fact that they are differentiated means there are two different demands, right? So there's a demand for Coca-Cola, there's a demand for Pepsi, but the two of them are interrelated. Why? Because if the price of Coca-Cola goes up, some people that were buying Coca-Colas, they may buy more Pepsi, and the other way around. So in the demand function of Coca-Cola is incorporating the price that Pepsi is that Pepsi is charging, and the other way around. In the demand function of Pepsi, the price of Coca-Cola is there. Again, you do the same. You write the profit maximization problem of each firm, taking into account that what the other firm decides for them is a constant, they can do nothing, right? You derive with respect to what they can decide, which is the price, right? Or the quantity, doesn't matter. Take it with respect to quantity because we want to do marginal revenue cost, marginal cost. So with respect to quantity, you find the best response functions, you write them in terms of prices, and you can do again the best response function in terms of prices and find the NAS equilibrium. And we see that that firm whose consumers are willing to pay more for it and who is more reactive to changes in the price of the competitor actually will be able to charge higher prices in equilibrium than the other. Okay? Of course, it also depends on the cost. So perhaps consumers love your product much more than the other, but it's much more costly to produce your product. Then we will have to see what happens, but you can solve it in exercises. Finally, the last type of competition that we saw was competition in location, right? Of course, in the real world, firms decide prices, quantities, and location. They decide all three things, but we saw them differently in order to understand how the three things would work together, would work separately in order to see, okay, but in real life, how would we put everything together? So in many cases, you cannot charge a different price than your competitor, and what you're selling, the quality and the quantity of what you're selling is basically the same. So the main decision is where to be. Well, if you have to decide where to be and people are homogeneously split, and when I'm talking about location, I'm not only talking about location in a beach or in the ideology spectrum. I could be talking also about how different your product is from the product of your competitors. But basically, with competition, with two firms competing in where to be, the two products are very similar, right? So Samsung and iPhone, they are very similar telephones. They have the same features. Why? Because they locate at the place where, all the features are very, very similar, right? Why? Because again, it's an NAS equilibrium. If the other is in the middle, you want to be in the middle. If the other is somewhere else, you just want to stick to them, but then they will move around until you reach the equilibrium. With two firms, with one firm, obviously, monopoly will be in the middle if people are equally located. With two firms, the equilibrium is both of them in the middle. With three firms, there is no equilibrium. With four firms, actually, we found the equilibrium where two firms are at 25% of the market, the other two are at the 75% of the market. And, I didn't get the heart attack, but it was close. Hopefully, this will be useful for you. And now, really, that's the course. Thank you very much. So I know there's a lot, but did it make sense, this video? Will it make sense when you go slowly through it? So enjoy the next 2 weeks. Just a second, please give me one more. I know I'm overriding time, but let me finish the course properly. So if it makes sense, please do it. If there are questions, ask me. One thing that I said in the other two sections, and I wanted to say here too, is I've been teaching this course or similar versions of this course for almost 20 years. Most of the time to undergraduate students who don't care anything and they just want me there. So for me it was sometimes to MBA students, but for this year with these 3 sections it's been particularly nice. So thank you very much for being interested, and I know you have struggled a lot, but I hope you have learned something, so that's good. Other thing I always say to my students is, you suffer me this year, perhaps you will suffer me next year again if you choose to. I promise no formula. It will be a lot more interesting in the sense that it's basically a course on what I really do. This is what I teach, but what I really do is research on behavioral economics. So I promise that elective course will be fun and interesting and less difficult in terms of math. So if you want to join, fine. And in any case, even if you don't, I was your micro professor this year. I'll be your micro professor forever. Meaning, if at any stage I can be helpful with career advice, whatever, you know where I am, where to find me. Thank you very much. Please fill up the survey for the course that we need. Thank you.